All right, so at this point, we should be pretty good at factoring. So now we're gonna do kind of the basic application of factoring. Here's why it's so important. So now we want to be able to solve polynomial equations. Okay. So the first type we'll start with is just called a quadratic equation. And basically what that means is a quadratic equation it's an equation where your highest power of x is 2. So a general quadratic equation will look like this. Ax squared plus bx plus c equals 0. And that x squared there, that's our leading term. Okay. So we have a couple of techniques for this. I'm going to go a little bit out of the order of the book because it's just a better arrangement, I think. One of your techniques, so there are some cases where we have a simple quadratic equation where the middle coefficient is 0. So we will use something called the square root property. Okay, that actually comes from section 11.1 of our book. This says that if we have some expression or an equation that's of the form u squared equals k, so if u squared equals k, then u equals plus or minus the square root of k. Okay. So that little plus and minus symbol combined, that just means whenever we have u squared equals k, we actually get two answers. One is the positive square root of k, and one is the negative square root of k. Because both of those things squared give us k, right? And that little symbol, that just means plus or minus. All right, now a couple notes on this. So one, k has to be positive or else we can't take the square root. And we'll see where that might show up when you're trying to solve one of these equations. Okay. And then what's the time when we want to use this rule to solve an equation? So this is for solving any time you have a quadratic equation like this. Ax squared plus c equals 0. So it's like this one, but there's no middle part, right? All right, so let's just look at a couple of basic examples where you can use this. It won't explicitly say that in the book at this point. That comes in section 11, but we can use it now. We know how to do some things that'll make this useful. Okay, so my first example, say we want to solve x squared minus 9 equals 0. Okay, we do know how to factor this. It's a difference of squares. And we'll look at how to solve it with factoring later. But it's really easy to use the square root property on this. So all we need to do is first move the 9 to the other side. Okay, now we can see we have x squared equals 9. That looks just like the square root property. So that means that if I want to separate, if I want to get the square off of the x, I can say that x equals plus or minus the square root of 9, which we know to be 3. So this means x equals plus or minus 3. And that's a general feature of a quadratic equation, is usually you have two solutions like that, kind of because of this property, because of the squaring in the quadratic equation that causes there to be two solutions instead of just one. All right. So that's a basic use of the square root property. Let's try, okay, here's when the square root property might fail. So let's look at example 2. Let's say we have 25x squared plus 1 equals 0. So that kind of looks like our quadratic form for the square root property. Maybe let's see what happens when we try to use it. Okay, so we're going to subtract the 1, and then we'll divide by 25. Okay, then we'll try to use the square root property maybe. So x equals plus or minus the square root of negative 1 over 25. Now, what's wrong there? Well, you should notice that minus this thing here is negative, right? Which is a problem for us. We don't know what that means. So to us, this is nonsense. And what it means when this happens is that there is no solution to this equation. And that's all you have to say. That will be the answer. Okay. So that's just something that can happen. If you ever get a negative under the square root when you're using the square root property, it means there's no solution. And that's the correct answer, not this. Don't reduce this. As soon as you see that negative under there, go straight to this. One thing to notice about this equation that can kind of tie it back to our factoring, well, notice how this one was a difference of squares. We do know how to factor that. This one is actually a sum of squares, which we know to be prime. So if you ever have a prime polynomial equal to 0, that is going to have no solution. It's always the case, right? Well, okay, not always. Whenever you have a prime quadratic, then you have no solution. Okay, so let's do one more really quickly. This is going to build up to our next rule in the next video. Okay, so example 3. X plus 1 squared minus 4 equals 0. Okay, so this looks kind of like our square root property. You might be tempted to FOIL this, but I'm going to say you should not FOIL it. So notice that if we ignore what's in here being kind of more complicated than usual, we have something squared minus a number. So that's exactly the scenario when we would want to use the square root property. If we only have two terms and one of them is a square, like the one with the variable is a square, move the other term to the other side, use square root property. Okay, so that's how I'm going to solve this. I will add the 4 to the other side. Okay, and now we have a thing squared equals a number. So we can think of this, everything that's in here, that's u. So altogether that makes u squared. And that will be k. All right, so that means to extract the x from the square, we use the square root property. That says that x plus 1 equals plus or minus the square root of 4. All right, and then I'd like to reduce that. So I have x plus 1 equals plus or minus 2. Okay, now this is what makes this one a little trickier. I have this 1 hanging out over here, and I gotta, after I do the square root property, then I can move the 1 over. So that means x equals -1 plus or minus 2. And now we actually need to separate this out and calculate the two different things. So we need to do the plus. So x equals -1 plus 2, or x equals -1 minus 2. And then just simplify those. So we get -1 plus 2 is 1 of our solutions, and -1 minus 2 is -3 as our other solution.